Okay, computer systems. So, with computer systems here, we're going to start off and say the computer system can be described as one that involves interactions between different actors. So when we're talking about the different actors here and the interactions, we talk about hardware, we're talking about software, we're talking about data, and we're talking about ourselves, humans, the people that interact with all these, the hardware, software, and of course data, the stuff that we do on the computers to get out some information and look at it. So systems are not just limited to interactions between these components, but between different actors of the same type. So you could have computers, contacting other computers. You could have a computer system could be made up of multiple computers or multiple programs. So you can have lots of these stuff going on in different little pockets and all connected together. And of course the internet is really an example, a very good example of a major computer system where all of the computers in this room, you can connect to the internet all over the world, which is just pages and computer systems here, there, and everywhere. So, the computer is a device that can be programmed to carry out general purpose mathematical and or logical computations. So going back to chapter 5 there, and chapter 5 talked about your general purpose machines and your specific purpose machines. General purpose machines are machines that can carry out, can do various things. Can do, can be a calculator, you can surf the internet, you have loads of different programs to do, or applications to do loads of different things, whereas a specific purpose machine kind of carries out just a specific function. So a good example of a specific purpose machine would be a calculator. It just does computation, and that's it. Although some of the newer calculators are getting closer and closer to phones, so I don't know we'll be able to use that in 10 or 20 years time. So a computer architecture is a specification of how different components are physically and logically laid out or connected. Think about architecture. An architect, they design buildings, they design things, and all the things that go in to a physical house or whatever. All the systems, all the plumbing, the foundations, the walls. Architects design all these, and of course, one of the things that architects get more money than engineers is they design some houses, with a few nice little details. But a computer architecture is a specification of how these different components are physically and logically laid out or connected. So almost all of today's computers share a similar architecture. Now, hopefully that will change over the next 20 years with the advent of quantum computing, which is a newer type of architecture, but it's going to be a good while before we see that on the ground, I would say. But at the moment, almost all of today's computers share a similar architecture, albeit at a very high level of abstraction. Now, what we mean by that is when you strip away all your kind of like graphics cards and all the add-ons, when you strip away them, like get away all, like lots of computers are putting on different things, like different types of graphics cards to make for gaming and that, and different computers can do different things. Like you might have a work computer for Word, Excel things. There can be different computers that have different add-ons that will suit those particular computers. But when you strip all of those add-ons away, and that's abstraction, when you get down to kind of the motherboard and the main computer components, that's where they have a similar architecture and all the stuff is kind of together. And if you look over there at your board over there, you've got things like RAM, CPU, I think they might, a power supply, all these kind of stuff. That board over there, which we might have a look at in a few minutes, they would be all the kind of architecture linked together, all the stuff connected together. So, the architecture is known as the von Neumann architecture, and it's first described by John von Neumann in 1945. So, this John von Neumann fella, he was an American-Hungarian computer scientist. An absolute genius he was. And von Neumann architecture contains it contains these 4 key things. So, a processing unit. So today these are called CPUs, central processing units, which are the brains of the computers, are just processors. But the CPU processes instructions, right? So that's what the CPU does. It executes or carries out some instruction that needs to be done for your programs or your applications to run. Memory, right? What do you think memory is? Your memory is where you store away stuff, either long-term or short-term. Like, can you remember what you did in maths yesterday? Some of you can, some of you can't. Some of you might have went home last night and locked that into long-term memory, did a bit of revision on it, did a few questions. Some of you mightn't have, depending there. So memory in a computer stores both data to be operated on and the instructions that are needed to operate on that data and the results. What do you want to do? So, like, at a very low level, things like computation, like if you were adding 2 plus 3, the result is 5. And that's all stored away in memory in these different memory locations swapped around. A bus. So try and think of a bus in real life as carrying people to and from somewhere. Well, in technology terms or computer terms, a bus connecting the CPU and memory. So this is one of the von Neumann architecture. And basically these are wires. Wires that allow the transfer of data from A to B. So when we talk about computers, we talk about the transfer of data from where it's in memory to be brought into the CPU to work on those instructions. So buses do that. They bring the data in and put the data back out. So they're basically a way of transferring data in and out. And input and output devices, if you look all around you, you've got input and output devices. You've got your keyboards, your mouse. They're all great examples of input devices. You've got your output devices, which are monitors, printers, and you've got various other examples there. There's just a few good ones there. They're the devices that allow data to come into the computer and for the output to come out. So I'd like you in your copies now to take down that diagram there. That is the von Neumann architecture, and it's really important, and you could be asked that in any of your exams, and to explain any of that stuff I just mentioned.